right, let me hit record, and we're recording. And then let me put today's coverage into Slack. So this is officially today's SQL Basics README that we're going to follow. And to get started, what I'd like for you guys to do is I'm going to put an article into Slack. So let's just take maybe 5 or 10 minutes. Instead of me blabbing on about this stuff, there's a lot of good documentation online, a lot of good articles and information about the differences between a SQL and NoSQL database. There's a lot of contentious discussion amongst developers about what's the right approach. So let's take about 5 minutes, 5 or 10 minutes. Go ahead and give me a thumbs up in Slack when you finish this article. But click on that SQL versus NoSQL, what's the difference article, and just read through it. We're going to go over some of the concepts in that article, but I'll let you guys read that before we dive in. And then give me a thumbs up in Slack when you do complete that article, and we will move forward. Recording. There we go. So for the purposes of this unit and such, a relational database is the same thing as a SQL database. And an example of that is PostgreSQL, which we're going to install today, and that's what we're going to be using with our Rails coverage. When we use the term non-relational database, we're referring to a database that simply doesn't use structured query language or SQL. And those are commonly referred to as NoSQL databases. So you have relational versus non-relational, and that's pretty much the same thing as SQL versus NoSQL. An example of a NoSQL database, obviously, is what we've been wrestling with the past 2 units. MongoDB is an example of a NoSQL database. So it uses documents rather than relationships to structure its data. So just want to get that out of the way up front. So just a couple of questions in here if you guys have any thoughts. So after reading that article, or maybe in your real life experiences, what are some examples of relational databases? What are some names of databases? If you've worked with any in previous careers, love to hear kind of your experience, the names of them, what that experience was like, maybe compared to your Mongo experience.
I played with PHP a little bit, with MySQL, and then playing in the PHP MyAdmin, using those third-party software.
Yeah, that's great.
Add stuff.
Yeah, so MySQL, as the article suggests, is the most popular open source database. So there's a couple of relational databases that you have to pay for. The largest one probably being Oracle. Right? So Oracle is, I guess, maybe the late 70s, early 80s. So that's an example of like a non-open source, something that you have to pay for. The software that we're going to be using, particularly Postgres, is a very, very popular, very well-designed open source SQL database, and that's what we're going to be using. But yeah, MySQL is definitely a huge one. And if you are comfortable with, I feel like the differences between relational or SQL databases, because they all use the same language, SQL. If you know how to use one, you can usually translate that knowledge pretty easily between types of relational databases. Whereas NoSQL databases like Mongo that we use, I feel like that's a little bit more like the Wild West. So that NoSQL bucket is very much, I think the technologies are very different in that bucket. So just because you know Mongo and can write queries in Mongo, that won't necessarily translate as easily to other NoSQL databases, the same way that learning a relational database that uses the SQL structured query language, that's very much transferable between databases in the relational world. So this is a very good skill set to have. What else? Does anyone else, any other examples of relational databases, or has anyone else used them in previous careers? I talked with Jason yesterday. I think Jason had some prior experience with relational. Anyone else?
I have been using, installing, and maintenance Microsoft SQL, which is one of the you have to pay for.
Yeah, SQL Server.
Yeah, Microsoft SQL Server. That's where my customer have installed in their facilities.
Oh, cool. Okay. Yeah, obviously like a Microsoft type product that will probably only work on PC, I would guess. I see in Slack some folks are putting Microsoft Access. Yeah, that's a really great example. So like in one of my previous careers, I had to maintain some HR software, this software called Resumate, which is basically just a fancy GUI, like a GUI wrapper over a Microsoft Access database. Like there really was not much to it. But at the time, I didn't really, I didn't know about databases. I didn't understand that. But now I can look back and be like, man, that was a pretty janky piece of software. Excel. So I think you guys are going to find, I wouldn't consider Excel a database. However, we're going to use Excel for comparison purposes because the way that Excel works and is set up, Excel deals with tables and rows and columns. It's very, very similar to the way the relational database is set up. And so I hope that that's going to help you guys catch on to it pretty quickly, because if you've used like a spreadsheet, then it's a very similar concept, which is nice. Yeah, I've used Oracle in a few transportation warehousing type atmospheres. Yeah, very nice. Cool, so let's move forward. So what are some differences between a relational and non-relational database that you guys picked up on reading that article? It can be terminology, how the data is stored, just any differences that stick out to you.
It seems like one of the main use cases for a SQL database is that it's ACID compliant.
And what does that mean? We kind of like brushed over that, but that's a really important concept. What does ACID, maybe if you don't know what it stands for, but can you give us an example of how that would be helpful or useful? Tell us about ACID, man.
ACID is it's an acronym, and frankly, I don't know exactly what it means. But the gist of it is that your data is like a specific type, and it has like it's more guaranteed to be consistent and there than not. But specifically what it means, I don't know.
Yeah, no, that's totally cool. And then Zarella, I think you had a comment. But yeah, ACID, I would encourage you guys to check out ACID. It's a pretty, you don't have to be an expert on it, obviously, but it's a really important feature, kind of an inherent feature of relational databases. So relational databases have been around since the 70s. They're much more stable, tested. There's more documentation on them. But Bank of America is not using MongoDB, right? That idea of acidity is very, very important, particularly for really large enterprise companies. If you want to get really high level, I like to think of NoSQL databases. They're good for startups. They're good for situations where maybe you don't know what your data is going to look like, or you don't know your data needs up front. Like, I just got to spin something up that's flexible. Relational databases are much more stable long term. A couple of examples of acidity. One of the really common ones is for banking. So you have debits and credits, right? So you need a database where if I withdraw $20 from my account, and let's say that there's a power outage or something happens, like Bank of America needs to know that I took $20 out of my account, right? There's a credit and a debit. So part of acidity means if those two transactions don't successfully write to the database, then the whole transaction is negated. So it's one way to make sure that those things are solid. Another example, let's say that I'm going on Ticketmaster to buy some Riri tickets. She already came to Atlanta, but I love me some Riri. So I'm going to be really upset if I try to order some tickets and I buy the tickets, I pay for them, but then Ticketmaster additionally gave those same set of seats to someone else. Like, that's not a really good business practice. Or airlines. So when you go to book a seat and I choose the seat I want and I pay for it, the database needs to recognize that and not assign that seat to someone else. Otherwise, the entire transaction is going to be negated. So some of acidity refers to that if the two transactions aren't written entirely, then the whole thing's negated. That's that would probably fall under maybe the isolation property. I'd have to look that up. But acid stands for atomicity, atomicity, I'm butchering that, consistency, isolation, and durability. So it's a very safe, redundant way to store data. And that's why, like, you know, financial institutions, anything like that, definitely are dealing with relational databases. They're not building, you know, MongoDB and such and embedding documents. Zarela, did you have a comment?
Yeah, I took a class like a long time ago, like 6 years ago or something. It was database modeling, and what I find out, it was very hard to do. I mean, like, to use it, it was both ways, like to use it and to do the modeling. The modeling was like kind of complicated because it seemed like you had to be very careful how you make the relationship between one and the other one. And if you didn't do it right, suddenly everything was a mess. So that was like something that it was a nightmare. But at the same time, it seemed like everything made more sense. But like to retrieve data, I think like that was kind of probably the cool part for me. To retrieve data, it seemed like it was very complete. Like you were able to sort through, like, for example, let's say I want all these people that are 20 years old and I don't know, and have this career and kind of thing. So you could get very specific. And I think that was kind of like the payoff. So it was very hard to do it at the beginning, to just do the modeling, but it was very rewarding on the ability to retrieve the information.
Yeah, that's an excellent point. I think that goes back to, like, to kind of paraphrase what you said, relational databases may take a little bit of planning up front. It's not just like a grip it and rip it type situation like MongoDB. You know, MongoDB technically does not require a schema. It doesn't require any type of structure. Whereas relational databases do insist upon a structure initially. Now, relational databases are absolutely, they can grow and scale arguably better than a relational database. But to your point, they do take a little bit more a little bit more of a thoughtful approach versus a NoSQL or MongoDB type database. Yeah. Any other thoughts about that? Any differences? We'll talk about some like specifics here shortly, kind of in the syntax and such. But cool. And then finally, just this last question. I kind of alluded to it earlier, but like, just generally speaking, what would be some potential use cases for a relational versus a non-relational database? The example I mentioned, I just think of non-relational databases. They're really, really fast to spin up. They take very little kind of pre-planning. So for startups, for situations where maybe you don't know what your data needs are going to be down the road, I think a NoSQL database, it's it's a newer technology, and I think it's really helpful for startups and just getting something deployed for MVP purposes or something. But for acidity purposes, for more stable structure, relational databases are definitely more reliable long term, and not to mention they've been around again since like the early 70s. They're just a more mature way to store data. Any other thoughts on maybe using a relational versus non-relational database? Cool. Okay. So let's just walk through a little bit. I don't want to like just blindly read this README. I want to get to actually installing some stuff and coding along. So let's just hit some of the things that we didn't just go over. Also, at the bottom of this README, there's probably 8 really good links to other like tutorials. Some of these tutorials will take you like an hour to walk through, like really kick the tires with SQL, or other blog articles and information. It's a really interesting topic. There's a lot of debate about different types of databases. So there's other resources for further reading if you want to take it further than what we're discussing right now. So the image I just put into Slack. So the relational data model is a highly structured table organization. So it's going to feel like an Excel spreadsheet for the most part, with rigidly defined data formats and record structure. So some of the terms that we're going to talk about in a relational in Postgres databases are tables. So each model or each resource that you have is going to have its own table So if we were today we're going to deal with authors and books. So instead of embedding books on authors like we would have done in Mongo, we're going to have a separate table for authors and a separate table for books, and we're going to make sure that they know about each other. Each new instance of something in a relational database is going to be like a row of a spreadsheet, and then the columns are going to be the fields, attributes, properties for that particular table. In a document data model, remember, it's a collection of complex documents with arbitrary nested data formats and varying record formats. So one of the great advantages to NoSQL is that it's really, really fast because we embed the documents. So if I'm looking for J.K. Rowling, I am assured that all of her books are right there. So I only have to look for that author document, and all the other information is there for me. However, there's a couple limitations. So remember that there's a 16 megabyte file limit in Mongo, unfortunately. Mongo, as you scale up, it's a little bit harder to like add other servers and services to like scale up your database. So those may be a couple of drawbacks. But the really good thing about Mongo is that it's super, super fast, though it does have some limitations. Here's another quick chart of some comparisons between SQL and NoSQL. So SQL, again, it's really mature. It's been around since the 70s. NoSQL is a relatively newer technology, been around since the late aughts. So SQL is also referred to as a relational type of database, relational model. NoSQL, again, is kind of like the Wild West. There's a lot of different varieties. They usually deal with like key value stores, just dealing with JavaScript objects, but there's a lot more variety with NoSQL. Whereas with SQL, you can be pretty confident that at least they're using structured query language. So at least that's consistent. SQL deals with tables, rows, and columns. NoSQL dealt with documents, specifically JavaScript objects. SQL is not easy to scale. NoSQL is easier to scale, just meaning that since there isn't a schema involved, it's easier to, just dump more information into that database. At some point, that's going to be like you're hoarding data. You're going to need to add some structure to it eventually, but that would be an advantage in NoSQL. SQL is much more ACID compliant. It's much more secure, mature. So again, any type of huge financial institution, banks, airlines, anything like that, Ticketmaster, they got to get my tickets right. They're probably going to be using a relational database structure. And some examples of SQL are Postgres, which we're going to install today, MySQL, which is the most popular one, which some of you have probably encountered that. And SQLite is a very, very stripped down, easy version of Postgres. And that's what comes out of the box with Rails. So if you spin up a new Rails app, it's going to give you SQLite out of the box. We're going to need to implement, we'll do this tomorrow, Heroku will not deploy a Rails app if it has SQLite. SQLite is actually just like one file that you put into your app. So we're going to have to add the Postgres gem to our Rails apps in order for it to deploy properly. We'll do that tomorrow. And then there are some examples of NoSQL databases. Any questions so far? Cool. So here's a screenshot. Again, it's very like Excel-ish looking. So this is a screenshot of Microsoft SQL Server, which some of you may have played around with in the past. But if you take a look at this screenshot, just a couple things I'll point out. So one, this does look like an Excel spreadsheet, right? It's very structured, very ordered. We have the columns, which are the attributes of last, full name, cell phone, etc. Each row is a new entry for a user. I'll also point your attention to, for example, if you look at that MI for middle initial, if you want to blow up that screenshot. One thing about relational databases, again, Mongo is very, very forgiving. If you have a middle initial, if you don't have a middle initial, it really doesn't care. Relational databases must have some value, even if that value doesn't exist. So I just want to point your attention, for example, if you look at that middle initial column, see how there's some null values? So even if that person doesn't have a middle initial, it's going to need to insert null in there. So relational databases can't just have empty things, right? It's more structured. Like I have a column of middle initial. All of my users either have a middle initial or null, meaning they don't. We couldn't really we could get away with that in Mongo. It didn't really care, but if something doesn't exist, we still have to put null in there. The other thing I'll point your attention to, if you look at that ID column. So in Mongo, we had to deal with that crazy object ID, letters, numbers, is a crazy looking hash. Relational databases are a little bit more, IDs are a little bit more straightforward, right? So they start with 1 and they count sequentially. We want our database to assign numbers for us. That's how we're going to set up our schema, because we want Postgres to manage those IDs. Let's say, for example, if we're looking at this screenshot, let's say that I delete the ID of 4, so Pate Drew. So if I delete number 4 and then I add someone else later on, that number 4 can never be reassigned. And that helps to maintain the integrity of the database. So you can only append new numbers to your database unless you like totally drop it or reset the database or something. Even if you delete something, that ID has been spoken for. Helps to maintain its integrity. And also, if you look at the screenshot, it looks like there's a couple of other tables. So we have users, we have books, genres, majors, transactions. So unlike Mongo, where we were trying to use Mongo the way it's intended with embedding documents, we're going to set up our data a little bit more. I think you guys are going to find it's actually going to be a better way to set up your data. So I think some of your apps actually really called for a relational database type structure. However, we were trying to squeeze as much as we could from Mongo and use it the way that it was intended, which is why we used embedded documents. Cool. Almost through here, guys. So a couple of other kind of semantic housekeeping tips. So in a relational database, data is stored in tables. So in Mongo, we refer to collections of documents. So in a relational database, a table would be the same thing as a collection in Mongo. Tables are organized by columns and rows, much like a spreadsheet. Tables are named according to what they model. So we're going to have a separate table for authors, a separate table for books. We're not going to need to embed books on an author. In the case of authors, each row represents one artist. So every row represents a new instance of that model. And then each column is called an attribute or a field, such as ID, title, or birth year. SQL, so structured query language. So this is the one thing that all SQL databases have in common, is that you can be rest assured that they're at least using this one common language, which makes transferring between these different types of databases pretty not too shabby. So it's a good thing to have on your resume. So SQL stands for Structured Query Language. SQL is a database language used specifically for relational databases. This is in contrast to non-relational databases like Mongo, which is essentially just using JavaScript, right? So how can we relate data between tables? So we can actually do this in Mongo, right? We talked about embedded or using references for our data. And some of you actually implemented references using Mongo, which was really baller. But that's really what we're going to be doing with the relational database. Everything is going to have separate tables that we relate to each other. So in this example, there's a screenshot here. This is taken directly from the Rails guides. So we'll talk a little bit more about the Railsy way to do this tomorrow. But in this example, how could we relate the rows in the books table to the rows in the authors table? So previously, we would just embed the books on the authors, but that's really not sustainable long term. So the way what we would do this is using a key, which is a field that is unique for each row in a table. So the key is often represented by using an ID. In fact, that's how we're going to, pretty similar to Mongo, that's how we're going to identify individual instances of something, is using their ID field. We refer to this as the primary key. So this is a really important concept, this idea of primary keys and foreign keys. We'll talk more about this tomorrow morning when we actually build some more relationships. But if you look at this chart, excuse me, the screenshot here, notice that both authors and books have an ID field. They have an integer data type, but an ID field. So authors has a primary key, which is an ID, and also books has a primary key, which is its ID. So every table has a primary key, right? But the way that we relate this stuff is to relate a book to an author, we would add a foreign key field of author ID. Sorry, I updated this. That should be a books table, not songs table. The author ID would be the primary key of the author the book belongs to. So this is how we're going to relate our data. Instead of dumping all the books on an author, it's really not sustainable. We're going to create a foreign key on the books table, and we're going to call it author underscore ID. That's kind of the convention, right? So that ID for the book is going to contain the ID of the author that it belongs to. And this is what we're going to work with the rest of the morning. But I just want you guys to, kind of be mindful of these concepts of primary key and foreign key. So every table has a primary key, but a foreign key is what we use to actually relate the data. So that's something we'll need to get used to. Types of relational databases, you can check out that section later. Let me hit this terminology and then we'll actually install Postgres. And it's going to be super, super smooth and easy. I know it. So here's just a little bit more terminology that we're going to be using. So the database is the actual set of data being stored. We can create multiple databases on our computer, usually one for each application. So that should be pretty straightforward. That's very similar to Mongo. So we had this one Mongo database that contained smaller databases, right? I guess you could refer to it more as like the Mongo engine. And then that Mongo engine had different databases for each application that you built. Same concept here. Database language is the language used to interact with the database. So everything we're going to be doing is going to be using SQL, or structured query language. In the previous 2 units, we used plain old JavaScript, which is pretty awesome actually, but we're going to be using SQL. The database management system is the actual software that we're going to be using. And all of these different management systems all use the SQL language. But some examples of the management system would be Postgres, which we're going to be installing, MySQL, MongoDB is another type of management system, although it uses JavaScript. But there's the system and then the language that it uses for queries. And then finally, the database CLI. So we use this with Mongo, right? We could type Mongo into the command line, and then we could get into the Mongo database engine and do our queries, hop into different databases and such. So Postgres has that as well. We're going to be typing in PSQL from the command line, and that'll allow us to get into our Postgres engine and play around with our data and tables and such manually as well. Whew, okay, so that's a lot of stuff. Any questions before we move forward to actually installing Postgres on your machine? Okie dokie. So there's a link in the README to, there's a lot of information in here into this README. A lot of this is like troubleshooting just in case we hit any snags. I don't anticipate that we will. But let's go ahead and get our Postgres installed. There's a couple ways to install Postgres. You could use Brew if you wanted. So Brew is what we used when we installed Mongo. Kind of the path of least resistance for today, we're going to actually install the Postgres app. So Mongo didn't really have a standalone native app that you could download. But this is a very quick, simple way to get Postgres running on your machine. And if I'm not mistaken, I actually think, I could be wrong on this, but we talked about how Ruby already comes installed on your Mac, right? Because Mac has some background processes that uses Ruby. So your Mac already has a version of Ruby installed. We'll probably be using different Ruby versions with different apps and stuff. So that's why we used RBENV, RBENV, if you will. Similarly, I need to check my math. I think that Mac actually comes with a version of Postgres already on it. However, we still want to install our own custom version because our Mac may be using that software for something else. I don't know. But we want to install our own custom stuff. So if you open up that README, we're basically going to go to the Postgres app homepage and follow their instructions to install their native app. It's this crazy looking elephant. The other reason we're installing Postgres via the elephant is because of the Alabama Crimson Tide, and that is their mascot. No, I'm joking. We could totally do brew, but this is a little easier. So go to that section where it says Quick Installation Guide, and you guys can go ahead and get started if you want. We're basically going to walk through these few steps. So the first thing we need to do is click that download button to download the DMG file. Then it should kind of prompt you to drag that into your applications folder. And then go ahead and double click on the Postgres icon to start up the Postgres engine. So go ahead and walk through those steps. And you may encounter some error messages and stuff, and we'll debug those. But go ahead and walk through those steps. So actually, if you will, go ahead and walk through those 3 steps. And if you're able to double click on the icon and it opens up, then just pause right there. And then we'll walk through to the next step to actually adding some information to your bash profile so that you can use the command line interface. And just let me know if anything's blowing up. Sometimes may encounter like some sort of permission issue error or something, but we'll get all that worked out. Let's see. Cool. Yeah. So it looks like Christine, because she did not have Postgres on her new computer. So if you look at Christine's screenshot, that's where we should be. So that should be good. You should see that Welcome to Postgres screen. You should also see in your menu bar a little elephant icon, and that lets you know that it's running in the background. So that's a good thing. Zarella, mine says can't be opened because of developer. Okay. Aaron already has a SQL server running. Aaron, did you already have Postgres installed?
Yes.
Okay, then you should be good then.
But when we did the homework and the SQL reading,
yeah,
I tried to run and create a database in Postgres, and I had some problems. It didn't really work correctly, okay. So I have it installed. Apparently, it's running. I'm not sure how I could shut that down because I don't know where it's running.
I would maybe quick and dirty. I forget the terminal command, the ps kill, but you could also go to Activity Monitor and see where Postgres is running and just kill it that way.
Okay.
Or check the PID and then kill it. Yeah, we'll get you straightened out. Zarella, mine says can't be opened because of developer. Do you care to elaborate on?
It said developer permissions, but I didn't drop it on the application, so that might be why.
Oh, okay. Yeah, you guys may encounter a permissions thing, and that's pretty normal. We'll get through it.
So if I drop it, wait, let me try it, see if it does work. Oh, okay. Yeah, I guess just drop it on the applications folder.
Yeah, drag it into the applications folder and then open it, try to click it. You may want to attach this to your dock, actually. It may be handy. There's scripts that we can add to your bash profile that will automatically get that engine running when you start up your machine. We can take care of that later. But yeah, if you double click on it and you get the image that Christine put into Slack, then that's where we want to be right now. Let's see. So JJ, unable to expand Postgres into downloads. Got it after double click. Yeah. So it should, yeah, so you had a zip file. Yeah, done zip it. Cool. example.
Okay, that works.
Okay. Yeah, go ahead and I guess at the 12:03, the screenshot that Christine put into Slack, if you guys wouldn't mind giving me a thumbs up on that. If you get the welcome to Postgres message, and then you get the elephant up in your menu bar. So that's means we're in good shape. Let me know if you're having any issues.
JJ, you want to share your screen for a second? And is anyone else having issues?
Yeah, let's see what's the. Yeah, Eric, yours may be a little bit different. If that gives you any problems, let me know. I have another command for Linux. We may want to install it a different way. So just let me know if that keeps giving you grief.
How do you close PSQL in the terminal like you would like NodeMon or Mongo?
Are you actually in the PSQL prompt?
Right. It just opened up. I might have accidentally pressed whatever that was. PSQL.
Open PSQL. Okay,
right.
That's okay. That's fine. Do a /Q, and that should get you back to the command line. And that's cool. That's a good sign. That means it's working. We're just going to add a line to your bash profile so that you don't have to like click on that button every time. And we'll do that next. Unable to expand zip. Do you have any space on your machine, JJ? Or
how can I check it?
Go up to your Apple icon, your top right. Excuse me, top left. About this Mac, but that's not the error you're getting. Go to storage. Okay, yeah, you got plenty of room. Unable to expand Postgres zip into downloads. Yeah, close out of that. Try hit OK. Drag that to your desktop. It's really weird. And then click on it again from there. Okay, so click OK. Hold down the Option key and click on your zip file there.
Hold on a second. Option. And click what?
Yeah, do the Option and then click on the zip. So get back to those options that we just saw. Okay, hold tight. Go to Open With. Yeah, Archive Utility. And if you scroll over to Archive Utility, I think that's what you were trying to open it with already. Huh. Okay. Hold tight, JJ. We can do a brew install for you. And in the meantime, if you want to Google that message, I don't know why Archive Utility isn't opening that. Let's see.
JJ, I can try to help you. Is anyone else having issues?
Christine, you mind if I put you guys in a breakout
Yep.
room just shortly and I can keep helping? Okay.
Yeah.
Cool. Let me put you guys in here. Okay. Alrighty. Yeah, is anyone else having any difficulty? See how many thumbs up we have. We got 7 thumbs ups. So we're still missing a few folks. So let me just let me know because I need to make sure you guys are good to go. Is anyone having an issue? Yeah.
Hey, Mark, what was the command in terminal to see all the running processes and kill processes?
Yeah, I don't have that one memorized. Tried
ps-ax, but that doesn't work for me. There was something else.
Yeah.
You could just go to activity monitor, I suppose.
Yeah, but I went there. I see Postgres, but it doesn't kill the PID when I type kill PID. Weird.
Well, on activity monitor, you should just be able to hit the X, and it should close it out, like force quit it.
Yeah, it doesn't. Dude, it doesn't force quit it. It's weird.
So in terminal, yeah, it's like PSAUX.
Here, I'm just going to share my screen just to show you.
Okay. See, so that's weird because you should have like. Did you filter it by Postgres or something? I don't know why.
Yeah, I filtered it by POS.
Huh. Yeah, go into the terminal and type in the PS space AUX. I'll put that into Slack.
Okay.
And then, yeah, let's find...
/ Postgres.
Yeah. So you probably want to grab the 4345554. And Aaron, had you installed Postgres with the Elephant, like you downloaded the app and stuff?
I did now, but not before.
How had you done it before?
However you do it with Ruby on Rails installation. I did it with the Mike Hartle tutorial.
Yeah, I forget if he brews installs.
I think it was brew install.
Okay.
I think, so. That seems to have worked. Why that still shows up, but it's weird.
I'm a wake up.
Oh, no, there it is. Still there. It's like I kill it, but it restarts. It just creates a new.
Yeah, well, if you install it with Brew and Postgres, there may be, and the Postgres app, there may be like, type in Brew services, Brew space services. Yeah, go ahead and click allow. It's fine. I bet you tried brew services list. I bet you didn't set any of these up, but okay, yeah. So it looks like your Postgres. So let's just restart it with brew. I think it should just be like brew services or you may want to stop it before you restart it. Let me see.
Yeah, that's what I want to do. I just want to stop it.
Yeah, I don't think there's a restart command with brew services. It's just stop and start it.
So just.
Yeah, and then you give it the name of the what you're trying to stop. If anyone else has their stuff working, if you guys want to like take a 5-minute break, feel free, and then we'll add the command line code here shortly. But go ahead and stretch the legs if you don't want to watch this stuff. Okay.
Can I ask a question?
Yeah. What's up?
I'm sorry to interrupt you. So I downloaded the Postgres and it says welcome to Postgres. Am I okay? Should I open it now or should I just stop there?
Sorry, Aaron, run that command I just put into Slack. You could probably do just a start PostgreSQL too, but sorry, Sanaz. So you downloaded the Postgres zip file?
Yeah.
Okay. Did you get the image that Christine put into Slack? Okay, then then you should be good.
Okay. Thank you.
So take a fiver. Yeah, Aaron, so if you installed Postgres with Brew, I would probably suggest just like completely getting rid of the app version that you downloaded. It may be fine, but there may be some situation where like it looks for the wrong version of Postgres or something. So, sorry. Did that help? Was that able to start back up?
Yeah. So it started, but I guess I'm not sure if it should it always be started and running.
Can you share your screen for a minute? So Brew, you can add. I'd have to go back to the Hartle tutorial. I don't know if he gives you the code to where when you start your machine, it just automatically starts the Mongo or the Postgres engine. I
feel like he did because...
Okay.
I feel like he did because yesterday in the tutorial I typed in like the whatever, I think it's PSQL, I think, in the terminal.
Yeah, I was going to say, so type that in.
Okay.
Library not loaded. Okay.
So as I was saying, like it's installed, but there is an issue because I couldn't use it with the tutorial.
Yeah.
That we did last night.
Yeah. So that read line, that is a Rails. Yeah, that's a Rails. Rails is barking at you for that, or Ruby rather. So you can access PSQL from any folder, like it's kind of a global command. Like go ahead and like get out of that morning exercise folder. Yeah, just try it from there. Okay.
You know, this is a larger problem related to the one I was having with Colin and Pry. Yeah. I was getting a read line error with Pry, and I think we reinstalled our bin and maybe and I think we reinstalled Ruby.
No, I'll send.
But it depends on what folder I'm in whether or not I get an error in Pry. And it's the same readline error.
Yeah. You need to install the readline gem to get rid of that. I think it's something with the, it must be like the 5.0.1 version of Rails, because I was getting that as well. So
really?
Readline is helpful. Like if you go into the Rails console or any kind of CLI, you should get that error. Well, I mean, you shouldn't get it. I'm not sure what the fix is yet, but I had to install that gem to get it to work. That shouldn't affect your PostgreSQL because PostgreSQL is like an agnostic, like separate entity. So I'm a little surprised that gave you an issue. But let me Slack you these lines of this thing here, and this let me send it to you privately because this would only pertain to you. Yeah, I think there's just some conflict with like maybe either the version of Ruby or the newest version of Rails, something really buggy that they'll get to. But see if that's helpful.
Before, how can I check and see if that gem's installed? Because I'm pretty sure that's already installed.
I think you can do like a gem. And it should also, based on whatever version of Ruby you're running, with our RBM, it would install different versions of that gem based on the Ruby version. Hold on one sec.
Huh. Oh, shoot. Okay.
So you got,
What was it called? RB
read line, I think.
the dash read line?
RB dash read line, yeah. So let me do this, Aaron. Let me, if you don't mind sharing your screen for a minute, 'cause that's a separate issue than Postgres. That's like a whole different ball of wax that we need to play around with. Just let me make sure that is anyone else having a Postgres install issue? And everyone's off camera. That's cool. Christine, did you guys get straightened out? You and JJ? Okay. Okay, so I'm going to assume that everyone's ready to move forward. We still need to get Aaron fixed up. Yeah. Yeah, so Aaron's having an issue. It's outside. It's more like a Ruby-esque. It's outside of like the Postgres realm issue. I'm going to have to like Google how to get him straightened out. But for the rest of you, let me put this next step into... So essentially, I wonder if we can just move forward if you guys just click on the PSQL button and we can set this up. But we should go ahead and get her done right now, though. Okay, so what I would like for you guys to do, so you all should have Postgres successfully installed locally, which is awesome. If you click that open PSQL button on that like welcome window, that will open up a prompt in your terminal to be able to go into the CLI for Postgres. That's cool and all, but we want to be able to just type in like PSQL from the command line and go in there automatically. We don't want to have to keep, clicking that button when we want to do the nitty-gritty in the Postgres engine. So what we're going to do is add a line to your bash profile that will give that command to make terminal aware of that command so that you can use it going forward. So here's the steps we're going to do for that. And I haven't forgotten about you, Aaron. We'll get you fixed up. Go ahead and for step 1, go ahead and open up your Atom bash profile. You can run that command from anywhere in your terminal because it has the tilde, which means it's going to be an absolute path from your root. If someone's doing dental work, that'd be great if we can mute that. JJ's doing dental work right now. Great. So go ahead and open up your bash profile.
Can I ask a quick question?
Yep.
So I'm going to run a command for bash profile in the terminal window that was just opened for me. Okay.
Yeah. As long as you have the $, right? So make sure that you're outside of PSQL and you're back to the command line prompt. And you'll be good. So you guys just downloaded Postgres 9.6, correct? So notice JJ's version was 9.6. Just want to make sure. So let me put the correct version in this path here. So once you open up bash profile, go ahead and paste this line, this export path line. Go ahead and paste, copy that and paste it into your bash profile. You shouldn't have too much stuff in your bash profile, so you can probably just put this like kind of at the bottom. This should not interfere with anything else, so it doesn't really matter the order. But paste that line into your bash profile, save your bash profile, close the file, and then close your terminal and reopen it. And I'll put those into Slack as well. And then to test this out, once you reopen terminal, and you can do this from any directory, any window, go ahead and type in PSQL. And you should get that prompt in terminal. The other thing, just to make sure, is that make sure that you have the elephant running in the top of your dock. It's actually, it may not be a bad idea to just close down your Postgres app and reopen it fresh. So just close down everything and reopen everything to kind of reinstantiate the environment. Cool. I have a couple of thumbs ups.
Hey, Mark, whenever we do the bash profile and we get the Atom screen, are we supposed to check if that exists, or are we supposed to copy and paste that in there and then save it and close the file?
You mean check to see if that export path line exists?
Yeah.
It shouldn't exist unless you've already installed Postgres, because that's kind of a custom line. Did you already have that in your bash profile? Oh, no. Because you played around with MySQL and stuff in the past, so.
No, that was on my PC.
Okay. Yeah, it shouldn't be a problem. I don't think any of you guys should have that line in your bash.
Okay. I missed the part what you said what to do whenever you type that in there.
So Aaron, you got it working? That's great. So do you still have the native Postgres app that we downloaded?
No, I got rid of that.
Oh, good. Okay.
I mean, I got rid of it before I reinstalled, so I'm not sure if it would have been a conflict or not, but I got rid of it.
Can you type in PSQL from the command line and get into the CLI?
I had to give it a name for database in order to get in.
Okay. So, that's fine. Yeah. Yeah, the first time I
typed in PSQL and it gave me a fatal error saying a database did not exist.
Yeah, so that's okay. Yeah, so that's actually a pretty common error. So is anyone getting, let me check the thumbs ups here. So those of you that gave me a thumbs up, I see 8 thumbs up in Slack. Do you get a prompt that looks like this? Let me do a screenshot. I'll put it into Slack. Because the issue that Aaron just had is a pretty common one, and we need to set that up the first time for some of you perhaps. But so if you get something like that, so my PSQL is a different version, that's okay. But you should see, generally you'll see like the kind of your computer admin name equals, and then the hash. So that's a successful, like you're there on the PSQL prompt. So if you get that working, go ahead and give me a thumbs up. If anyone else is not getting that, or if you're getting some sort of error, just let me know if you want to come on mic. There's a couple of, kind of common things that can happen. We'll get you straightened out.
Yeah, I'm still getting the command not found when I type in PSQL.
Okay. Do you want to share your screen, Brad?
Sure.
Did you guys already talk about version number? That was the issue with JJ.
What was his issue?
We just had the wrong version number in the bash profile. So.
Yeah, I updated it to the command I put out. The command I sent out said 9.6, which should be the most recent.
Yep.
Yeah, so that should be fine. Okay, Brad, go ahead and open up your bash profile one more time. Let's make sure that we got that export command in there. So you, yeah. Yep.
I don't know if it's still that.
Yeah, let's just check your bash real quick.
Yeah, that's what I was asking about. I don't see that exactly in there. You said I wasn't supposed to, though?
Did you paste in that? Yeah, I need you to paste in that command.
Oh.
Yeah, that's why I put it in this slide. Yeah, so go ahead and paste that in.
Okay.
You can just paste it at the bottom. Okay, save that file.
There we go.
So close out of Atom. See the elephant in the top. Close that out and close down your terminal and reopen everything.
Close this right here.
Yeah.
Just close my terminal.
you close down the entire terminal app. I would just close the whole thing down, just to be completely sure. And then see the elephant at the top. Let's go ahead and close down Postgres and restart that. Okay. So start Postgres, then open up your terminal, and then type in PSQL, and we should see that prompt that I put into Slack, that screenshot.
Just PSQL?
Yep. Did you restart PSQL? Did you restart the app?
Oh, no. How do I do that?
Hit Command Space and type in start typing in Postgres. Okay, see the little elephant right there? Okay,
yep.
So that lives in your applications folder. You may want to attach that to your dock down in the bottom, just so you have it handy. But remember, This is an application that we downloaded. So when you want to start up Postgres, you'll need to click on it like you're opening any other application.
Okay.
Okay. So now, see if you can type in PSQL. Perfect. Okay. So can you remember those processes, like the steps?
Yeah.
We'll get the hang of it. Okay. Cool. All right. Cool. Somebody's launching missiles. Okay. Is anyone else was anyone else not able? I see 12 thumbs ups. So if you haven't given me a thumbs up, please do, so I can know to move forward.
Hey, Mark, can you explain to me why mine would work without having put that path in my bash profile?
Because you installed yours using Brew. So Brew is a whole different beast. It probably added, in your shim, it probably added that information already. So Brew is handling like the starting and stopping of your engine. So we're installing the app, so it's two separate things. It's still installing the software. It's just the way, two different ways to do it. But Brew is taking care of your like PSQL CLI command. Okay, cool. I'm going to move forward, guys. So if anyone's still having any issues, I'll definitely get you straightened out. Just ping me or ping Christine. But I want to move forward so we can get some stuff done before lunch. But all things being considered, that really wasn't that bad. It's pretty easy install. So great to work all around. If you want to go back to the README, I'm going to start at the PSQL commands section. I'll put the README back into Slack. So this section, I'm going to share my screen and do kind of a quick demo. You guys are welcome to follow along. I'm not going to stop to like debug or anything because we're going to do the CRUD actions, here in a few minutes. I just want to quickly run through some of the commands, some of the features. So you're happy to code along if you want, but I'm just going to fly through them. And all these commands are in the README as well, if you do want to follow along. So I'm going to share my screen, and we'll get cranking here. Okie dokie. So I'm going to start right here on this PSQL command section. Make my screen a little bit bigger for you guys. And I'll clear that out. Okay, so here's I'm not going to put these into Slack either if you guys just want to follow in through the README. But I just want to point out, so if you want to check some of the man pages for Postgres, you can type in help. And this gives you kind of the entry point to some of the help information. You could do like / question mark, and that'll give you some of the, pretty much anything in Postgres is going to have that / and then a letter or a command. So anytime you see that /, that's a Postgres versus SQL. The / means that it's, or a / or whatever it is, you guys know. That means that it's specific to the Postgres database engine. I think someone mentioned this yesterday. You'll see this a lot in when you're dealing with the databases, just because there's not enough real estate, visual real estate to show everything. So if you see this little colon down here, this just means like kind of to be continued. So you can hit the space bar to keep going down, or if that really gives you fits, you can always just type in Q to go back to kind of the main prompt. So that's kind of a bash, kind of a bash type of environment. So you can always just do that Q to exit out of that when you see the colon. Cool. So now that I'm in my main kind of area, so I have Mark Wright and my pound sign. Really quickly, if I want to check all of my databases, you can do \L, like so, for list, and that'll show you all of your databases. Now, I am assuming you guys don't have any or not a lot of databases, and that's okay. But that's how you can see the list, so that \L. If I want to create a database, the command would be, so unlike Mongo, which is really user-friendly and created a database automatically for us the first time that we tried to persist data, we need to be more explicit with Postgres and relational databases. So for this, I'm just going to type in DemoDB, if I can spell it correctly. And then the really peculiar thing about Postgres is, in SQL queries in general, is that you must put the semicolon at the end. Your queries will not work, and your commands won't work unless you have that semicolon. It's something that it's very peculiar about. So let me create the database here. It already exists, sorry, so I'll do this again. So I'm going to drop the database. And then I dropped it. So there you go. That's how you drop a database with the drop database command. So let me create that one more time. Okay, cool. So now we should have a fresh database. One thing you may notice is this uppercase. So some of these commands are uppercase and then some stuff is lowercase. We'll be talking about this, the rest of today and tomorrow. This is mainly a convention. So these commands will work if everything's lowercase and such. But sometimes these SQL commands can get really dense. And so it's a convention of SQL to capitalize the key command, the command keywords that are part of the SQL query language. It's just a convention. It helps with readability, but that's kind of the best practice. And again, it helps with readability. It'll work lowercase just fine, but it definitely makes it more readable when you have like really crazy queries. Okay, so if I want to connect to that database, that's going to be a \C, and then you pass in the database that you want to connect to. So you should get a message, you are now connected to database, etc., as user Mark Wright. Well, you shouldn't see Mark Wright, but if you do, let me know. So now that I'm in this database, so I have a database, a DemoDB. If I want to see all of the tables that represent all the models in my database, I can do that with this / or \D. And right now it's saying no relations found because I haven't created any tables, right? It's just kind of an empty shell of a database. So I'm going to start one right here. I'm going to grab this code. We're going to be putting this into a proper file here in a minute, but I'm going to create a Pokemon table to capture all my Pokemon data. So the first field is going to be a number field. This field is going to be of data type integer. It needs to be unique. So in this example, this number field is going to kind of be my ID for each Pokemon. So I want it to be unique. I don't want to have two Pokemons with an ID of 1, for example, because then it's just going to mess up the integrity of my database. So I want this to be an integer data type. I want it to be unique. And I also want it to be a primary key. So we talked about primary keys and foreign keys, and we'll talk more about this tomorrow. But this primary key statement, it's going to make Postgres create sort of an index underneath the hood. It's very much like the index of a book. So anytime, let's say that this is just a huge tens of thousands of Pokemon or tens of thousands of users in my database, at some point it becomes really inefficient if I'm looking for Mark Wright or the user with, well, if you're searching by an ID number, it's pretty exact, but if I'm looking for a user that goes by Mark, my database is going to have to go through every single row, every single instance of a user in my database till it finds all the marks, right? But this indexing feature is very much like the end of a book. And so underneath the hood, Postgres makes those searches a little bit more efficient. And we don't need to know how it works or the inner workings of it. But it basically says, okay, if you're looking for a user, M through R, look in this part of my database. This is where I've stored that information. So it's a really cool feature. And that's what this primary key is doing. It's essentially adding an index feature to our data. This next field, just a name field, varchar is a data type. Varchar is really cool because varchar, you can actually tell it explicitly how long you want this. This is essentially a text field. But unlike the text data type, varchar allows you to pass in things like I could do varchar and then put like a maximum of 100 characters or something. So varchar and text, they're pretty similar, but varchar, if you want to like set a maximum, you could do that. And then not null. So this would be similar to a validation of like must exist. So I can't persist a record to the database unless it has a name attached, right? So if something doesn't exist, Postgres just sticks null, a null value in that row. However, for this validation, it's called a constraint, actually. I'm saying that name must exist for this to save to the database. The same thing with type. It's going to be a varchar, which stands for variable character. And then that has to exist. It can't be null. And then the description is just going to be varchar. So actually, I could leave description blank, or I could try to save a record without description, and it'll save it, no problem, no big deal. This is, for all intents and purposes, you could kind of think of this as a basic schema. So Mongo didn't require a schema. Mongoose allowed us to create schemas to add some structure to our database. Again, we're going to put this into a proper schema file, here in a few steps, but that's kind of what's going on here. So I'm going to create this table with these fields and attributes. And then when I hit enter, you get this create table, kind of this kind of feedback. So let me do another \d, excuse me. And now I can see that my list of relations, I have one table, a Pokemon table. Here's who owns it. So we're not really going to go into the owner, but with databases, maybe you have like an admin user who has certain permissions. Maybe I have different permissions and such. So that's what that refers to. Cool. So if I want to select, sorry, any questions so far? We're going to do this a little bit more with books and authors here shortly. But kind of the most basic way to read from a database is select from. So for this command, I'm going to do select, or this query rather, select all. So this kind of star or splat, whatever you call it. This is saying select all the rows or all the instances from the Pokemon table. So this is a very common query. So when I do that, what it returns is a result set. That's kind of the proper term for what a query will return to you. And so this looks kind of like an Excel sheet, right? So I'm getting the columns, number, name, type, description. However, I don't have any rows. So remember, a row in this case would be one instance of a Pokemon. So that's how I could read all of the Pokemon. But let's insert one, so I actually have something to work with. So let me grab this line right here. And this is a pretty basic SQL way to create data using this insert statement. So for this one, I'm going to insert into the Pokemon table. And then you want to pass the arguments in parentheses for the columns that you actually want to add data to this row for. So for this Pokemon, I'm going to give it number and name values. Then you use this SQL keyword values, which is why it's capitalized. And then you pass in the arguments that pertain to the columns that you're trying to write, the fields. So in this case, 001 is going to be the number, and Bulbasaur, I'm probably butchering that because I don't know Pokemon very well.
Bulbasaur, man, come on.
Bulbasaur? I don't know it. I don't know. I know Arrested Development. I don't know Pokemon. So that's going to be the name of this Pokemon. And remember to be sure to have the semicolon there. So if I hit enter, I get an error. Does anyone want to explain the error that I'm getting here? Why wasn't that successfully written to my database?
You didn't put anything in type, but you specifically said that type cannot be blank.
Cool. Yeah, thank you. Exactly. So error, null value in column type. So I put that not null constraint. So I must adhere to that. So let me actually put a type in there. So I'm going to insert into Pokemon. I'm just going to add that type field, and then that'll be type of grass. Cool. So I get, this is kind of a basic return statement. So it's going to insert this first value. It's usually 0. I need to go through the documentation. This is kind of a legacy thing. It refers to some other feature of Postgres like back in the day. I would guess that you're always only going to see 0 for what we're doing for the first value. For the second one, it just tells you that it inserted one row into your database. So now if I do another -d, sorry, not a -d, let me do a select from Pokemon. And now I have one Pokemon, which is cool. Let me add quick and dirty. Again, we're going to put this in a proper seeds file here in a bit. But I'm just going to slap in a couple of more. So I just copied and paste those. And now if I do another select from, now I have 10 rows of Pokemon, 10 instances. And I didn't set up this schema to automatically increment. There's a SQL statement called serial that we'll play around with. Serial makes sure that Postgres puts like the ID number, it increments it by 1 each time. This one we just put in manually, so that's why it goes like 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 25. It's because that's just how I set up the data. Let's say that I wanted to update one of these bad boys. So here's what an update would look like. So this set keyword should be very familiar. We had $set in Mongo, so that's somewhat similar. So I have the SQL command update, then the table that I want to update some information inside of, and then the set command. So I'm going to set the type to fire. Where is another a read command. It's another way to search for something. So where is a way to get a little bit more specific. You can pass in specific values for fields that you're looking for. So for this one, I want to update the type to fire for the Pokemon whose number equals 5. So in this example, 5 is going to be Charmeleon, a ghost. So I want to update this to fire. So if I run that, I see update, it updated one record, one row. So now if I do my select from Pokemon, now we see that number 5 is now here at the bottom because it's the most recently updated. And we see that that was updated to fire. So that's a very simple update command. To delete, we just use the SQL keyword delete. So here I'm going to delete from the Pokemon table the Pokemon where name equals Pikachu. I think I got that one right. And so now I deleted one instance right there. And now if I do select star from Pokemon to get them all, now I can see that Pikachu, which was number 25, he or she, I don't even know the gender, has been deleted. And then here are a couple of other quick and dirty commands. So to drop a table, it's the drop table command. This if exists, for example, I think MySQL, you can just run drop table and then the name of the table. Actually, Postgres, you can run drop table and then the name of the table. This if exists is just like the preferred way if you go through the documentation. It gives you a little bit better error handling. So if a table doesn't exist or if it does exist, but maybe you have some dependencies on that table, so it can't just like delete it willy-nilly unless you give it some more instruction. So this is just drop table if exists. It's just kind of the proper way to drop something. And then drop database if exists. So if you want to drop the database, if I wanted to drop my demo DB, I would have to like get out of the database before I could drop it. So I couldn't drop this while I'm inside it. And then to exit the PSQL CLI, you can do Q like that and get back to your main command line prompt. Let's see if we have any questions. Sorry, I kind of flew through that.
Mark, you may have already mentioned, but what about the description field? Does that not have to have a null value, or?
Well, it does have null. It doesn't print it out in this view. Yeah. But yeah, the description field, we didn't put any kind of constraint on it. So it could be there or not be there.
Right on.
Yeah. Cool. Let's how are you guys, let me stop my screen share for just a second. How are you guys feeling? Do you guys want like a 5-minute break before we move forward? Do you guys want to press on? Who'd like a 5-minute break? Okay, let's take a quick 3-minute break. I know I've been keeping you guys. Let's take a 3-minute break and then we'll finish up. So let's come back at like 12:55 and we'll keep rolling. We're in good shape though. All right, friends. Let's keep it moving here. I just posted a screenshot into Slack just really quickly to recap a couple of points. So our schema, so every applications database will have one or more tables. And as you recall, each table stores information about a particular model. We're about to play around with authors and books. and each table has a schema. We're actually going to put this in a proper file and do it the correct way. But the schema, very similar to our Mongoose schema, it's going to define, for example, the column's name, a column's data type, and then any constraints. So you guys should be pretty savvy at this from Mongoose. It's going to be very similar. There's a section here on common data types. So if you guys, there's a lot more than are listed here. And if you want to check them out, that link, that and many more link, just goes to the Postgres documentation. So if you want to check that out, go for it. But these are some of the most common ones, like Boolean, integer, float, text or varchar, null, date, and time. And then constraints. So constraints are when we kind of limit what can go into a particular row. So for example, we just used not null and unique. And so that's what a constraint is. You could probably think of it very similar to like a validation that we used in Mongoose. I'm going to skip over this. There's a diagram in here of, we have an internal tool that we used called Garnet. Let's talk about this a little bit more tomorrow when we talk deeper about relationships between our tables. But this is kind of the ERD diagram for this internal tool that we use. And you can see that this thing has 12 different tables. I doubt that when we conceived Garnet that it just immediately exploded with 12 tables. It probably started with maybe 5 or 6, and then over time it scaled up. But we'll talk about that tomorrow when we talk about relationships. Let's get to our kind of code along time. So what I would like you guys to do is, if you go into your student labs folder for today, I have a library. It's called library SQL. And that's going to be kind of some starter code. We're actually not going to, we're going to be doing everything within PSQL itself. We're not going to be changing any of the files. But go ahead and CD into your student labs folder. And we'll get started on going through the CRUD, SQL CRUD with this app. So go ahead and CD into it, then open it in Atom. And don't go into PSQL or anything yet. We'll get there here shortly. But again, we're not going to be changing any of the files. We're just going to use those files as kind of our base. I will go ahead and start my screen share again. Cool. So I do a PWD. So I just dragged that library SQL to my desktop. I have a version on my desktop, so that's one that I'll be using. But yeah, let's walk through the CRUD commands using this app, and let's walk through some features and seeds and such. So I'll put these first instructions into Slack. So the first thing we want to do is let's create our database for this app. Now, previously in my walkthrough, I created it from the SQL prompt directly from inside the Postgres engine. I did a create database in the name of the database. PostgreSQL, because it's so user-friendly, it actually gives us commands that we can run directly from the command line without having to go into the Postgres database. Either one is valid, but I just want to make you guys aware of it. So let's say that I'm not inside my database right now. We'll be doing this in Rails actually, because we'll do some Rails commands that will instantiate our databases without actually going into the CLI prompt. But what you guys can do is a create DB, and this is a Postgres command. This is not a SQL command. This is Postgres. And then the name of your database. So let's create one called library for this example. And then you shouldn't get any kind of feedback or something. I wish it would at least tell you database created, but that's okay. And then like it says here in the screenshot, just want you guys to be mindful that this is a command line utility that ships with Postgres. It's an alternate to using the SQL command create database and the name of the database. inside the PSQL prompt, PSQL engine. So go ahead and give me a thumbs up in Slack if you don't mind on that screenshot, if you got that working correctly. Just want to make sure we don't have any kind of permissions issues or anything funky so far. I think we should be pretty good. Okay, cool. That works for me. Got like 8 thumbs ups, 9 thumbs ups. Okay, cool. So let's inspect our schema, which is in that screenshot. So if you opened up the app in Atom, let's take a look at what our schema file looks like. So if you want to open up the schema.sql. Now in my walkthrough a while ago, I pretty much just like copied and pasted this data into Postgres directly. And that's fine. You know, it's just probably a little bit more proper to put it into an actual file. So that's what this is. I created a schema.sql file. These first 2 lines should be pretty familiar. So remember in the Mongoose world, we put, if we were going to like seed our database or something, remember that we did like the name of the model and then the remove method, just to kind of like start from scratch, start fresh from scratch, like wipe the slate clean. So this is a very similar pattern. When I run this file, if I have a books table and an authors table, if those exist, I just want to drop them, just completely get rid of them, blow them up, because I'm going to create them again from scratch. So very similar to what we did in Mongoose. So in this example, the first table we're going to create is an authors table. And this time we're going to do it properly with an ID field. So is the ID for authors, you can put this into Slack, is this a primary key or is this a foreign key? Right here on line 5, is this a primary key or a foreign key? Let me make this bigger. Nice. Yeah, it's a primary key. That's great. Excellent work, folks. And then notice down here that books is going to have a primary key as well. Cool. So yeah, so we have this primary key. We have this serial, which is a SQL command. So serial is telling Postgres that we want Postgres to do the incrementing. So we're going to start at 1, and we want Postgres to assign a new ID number to each row, each new author that we add. We want Postgres to maintain its integrity. We want Postgres to handle that stuff because I can't remember which ID I added previously and stuff. And this is also the primary key constraint. So remember, primary key, if you want to go through the documentation, that's going to add some indexing, which is going to speed up our database a little bit. It's just going to help make our queries a little faster. Name, varchar. So here's an example. If you go through the documentation, varchar will allow you to assign kind of a maximum value. And so just for funsies, this varchar, we're going to put a constraint. It can only be 255 characters. Same thing with nationality. And then birth year is going to be an integer. I think we could get away with INT here as well. But we'll go with integer. Cool. Then the books table, the same thing with the ID, serial, and primary key. Varchar, publication date is going to be an integer. And then how about this author underscore ID field? Is this going to be a primary or a foreign key?
That'll be foreign.
Yes, it's going to be foreign. Absolutely. Yeah, really good work. So the idea is that instead of dumping all of the books that, Stephen King wrote, it's pretty inefficient to dump all those books into the authors table, which, by the way, is pretty much what we did with embedded documents in Mongo, which totally has its place, the right tool for the right job. We're going to have 2 different tables, and the way that we're going to connect them is that it makes sense, instead of dumping the IDs of every book that Stephen King wrote into like some sort of books array, that would be impossible to keep track of. It makes sense that we put the ID of the author that wrote the book in the books table on that specific row for the book. So we'll talk a little bit more about relationships tomorrow, but that's the way this relational database is set up. Cool. So we walked through that. Let's load the schema into our database. So this is how we're going to do it from the command line. So I want to make sure that everyone's still at the command line prompt, that you haven't gone into PSQL yet, because we're going to do this from the command line. But the command to load this into our, to create our, well, we already created our database, but to create these tables is PSQL -D. So -D is just kind of a shortcut flag for database. And then you pass in the database that you want to, dump some information into. And then we're going to use our little, kind of less than or little shovel because we're going to push something into a library. And then we can put the name of the file. So this is essentially saying, run the SQL program and push this file into the library database. So we're going to create those tables. Well, the first thing we're going to do is drop the tables if they exist, which they shouldn't, and then create the tables. So if we run that, so now we do get some messages. Now Postgres is being a little bit more polite. But you guys should see something like a notice, table books does not exist, which is fine. So it skips the drop table because it didn't have anything to drop. That's fine. Same thing for authors. And then it creates 2 tables. I wish this at least said like the name of the table that it created, but it's a little succinct for my taste. But there you go. So that's what we should be getting there. And if you're interested, you could also do this directly from Postgres. The way to load data when you're in the PSQL environment, well, it's pretty small, but you can see it. From inside the library database in PSQL, you could also run that \i and then the name of the file. So \i is kind of the command in the PSQL prompt to run some sort of file, just FYI. But you could do it from the command line or from inside of PSQL. Cool. Okay, so I wanted to show you guys 2 ways to load up a seeds file. One of these is specifically for Farouk. You're my boy. We're going to load a CSV file because he used one in Project 3, which is pretty awesome. And we're also going to load one just kind of the regular way. So we'll see 2 ways to do this. And given that, Excel data is very relational, it makes sense. It's not a bad idea if you're trying to create some seed data just to do all that heavy lifting in an Excel file or a spreadsheet, export it, and then dump it into your database. That's not a bad strategy. But let's see how to do this with straight SQL. So if you take a look at the seed.sql file. So this is some dummy data. We're going to insert some authors and some books just so we have some data to play with for lab time, which we may not get to today. But you can take a look at this if you want to. This truncate table is a SQL command. So truncate table will basically empty out everything inside the table, but it won't delete the table. It won't drop the table. So there's dropping the table, which completely removes it, deletes it, or you can just truncate it, which just like kind of empties out everything inside it. Much like when I was pumpkin carving this weekend and had to empty out. I don't know if anyone does pumpkin carving. I'm kind of a bah humbug for Halloween, but man, carved a pumpkin, like roasted the seeds. It was amazing. Highly recommend it. So that's what truncate does. It just empties out the table. Alter sequence. So you have the option when you're telling your database that you want your database to create the ID numbers for your rows. Let's say that you wanted it to start at 10 or 20 or 100, some arbitrary number. You could tell it like the number, where you wanted it to start. Another thing to keep in mind is, let's say that I had 100 authors in my table, and let's say that I ran truncate table, and then I started adding new authors. So I had 100 authors, I removed all the authors. However, since I didn't totally delete the table itself, when I start adding new authors, it's going to start at author number 101. So that's something to be mindful of. Remember earlier when we looked at that screenshot of the Microsoft Access database? I forget which one it was. But I suggested that, hey, if we delete ID number 5, it's not like that number 5 is going to be replaced with a new person or new user. That number 5 cannot, be used anymore. It's kind of like a retired jersey number or something. So it's the same thing here. And I just mentioned that. So if you want to tell your database to start over with a particular number, So that's why we're adding that here with this alter sequence. And then the rest of this, here's some authors and here's some books. So you guys get the idea. Let's load our seeds into our library. So we can do that from the command line as well. And the command is going to be psql-d, same as up here. And we'll tell it the database that we want to dump this stuff into. And this time we're going to run the seed SQL file and dump the information into library. So let's run that. And so now we do see a lot of insert statements. I forget how many books and authors are in here, like maybe, I don't know, like 90 or something total. So it inserted all that data. So that this is a good sign if you see this. Now I put together a CSV just really quickly. Let's say that you do have some nice Excel data that you want to put into your database. I mean, this can be kind of time consuming, right? Like insert into, like doing all that stuff. But let's say that I have an Excel file that already has some good data, or you download a data set online. There's a lot of great data sets, particularly with data science. So if you check out this books.csv file, I just added one book, but just to give you an idea. So actually, if you want to put it into Slack, what does CSV stand for? There's several varieties. There's TSV, there's CSV, but what does CSV stand for? All you Excel nerds out there. Yeah, comma separated values. There's also TSV, which would be tab separated values, but yeah, that's great. And you can kind of see that here, right? There aren't any extra white spaces, title, comma, publication date. There isn't like a space in between. There's spaces in between the title of the book. I mean, we definitely need that, but this is a very like bare bones kind of an essentials type of file. So it's really, really lightweight and convenient. So let's say that you exported some Excel data and it would look something like this. Let's load that into our database as well. So to do this, let's actually go ahead and go into our PSQL prompt. So if you want to type in PSQL, we'll do this directly in the prompt. And then I'm going to just paste this in because it'll be a little easier. But we'll walk through what this means. Cool. So once you're inside your PSQL prompt, the first thing we need to do is make sure that you connect to your database. So go ahead and do a \c library. You're now connected to the database library as your username. And then we can run that command to upload our CSV file. So when let me make that a little bit cleaner. There we go. So \copy, again, that's kind of a good hint that it's a PSQL command. Anything like kind of / or back. Is this a / or a \? I'm brain farting today. Somebody wants to straighten me out. So we're going to use this copy command. Then we're going to tell it the name of the table that we want to put some information into. And then as arguments, the order is very important as well. We're just telling it the kind of the headers from this seeds file. So we're going to try to pass in title, publication date, and author ID. And then the file that we're going to grab the information from. So we're grabbing this from the books.csv file. And this is a relative path. So it just so happens that when we entered into PSQL, we were already in this library folder. So if we were like on our desktop or something like that, we may need to make this more of a relative path with .. or whatever. \/ Okay, thank you guys. I usually have my my DBA. Something like that with Tom. We usually just have our database administrators handle all this, but that's cool. So we're going to grab that CSV file, and then this with is another SQL statement or SQL keyword. So we're telling it the format is TSV and the header is true. So that means that it's going to look in the file and it knows that the first line of that file is going to consist of the headers. So like title is not the name of my book. publication date is not the date, and author ID is not, literally the number. So just some specification there. Okay, cool. So if we run that, copy 1, so that's good because we only had 1 book just for demo purposes. And now the quick and dirty, if you guys remember, if someone can help me out, how would I see what tables I have in my database? So I'm already in my library database, but if I just wanted to quickly check what tables I had available, what would that command be? You can put that into Slack.
\D.
Yeah, \D, thank you. So yeah, so that'll show me my list of relations. Right now I have authors and books. And then this author's ID sequence, that has to do with that indexing that we talked about earlier. We don't need to worry about that. That's just like some nice Postgres goodness. But it looks like I do have an authors and books table, which is the most important thing. Now, if I wanted to see all of my authors, what would be the command for that if you want to put that into Slack? I just want to see them all. Close. Yeah, select from. Yeah, so that's the first part. What else do we need to finish up that statement, that query? Cool. Nice. So is this going to work? What else do I need? Yeah, so that semicolon is really important. Just let me run this without it. It just kind of like gets hung up. So you see it went from like an equals to that single dash. And then if I try to add a semicolon after it, it works, but it's very similar to like if you're in the node REPL or the terminal or whatever. Just need to make sure that we finish off our statements with that semicolon. Very nice. So yeah, so that returns all of the books, all the authors rather. What do we call the view after we do a query? What's like kind of the technical term for what's returned? I think I mentioned it like once.
I have a question mark. When you have library equals and then the hash, what's the difference between library dash hash?
Because it's waiting, you didn't finish the statement. This is saying like, hey, I'm still waiting for something else.
Oh, I didn't do that yet. I just copied and pasted the library thing. And then right from there where you have copy 1, and then it goes library, and then you did your \D. Right after I copied and pasted it, it switched to a dash instead of an equal sign.
Oh, you may have put an extra space in there or something. So maybe you'll see the single dash if there's some extra space or character. But essentially, Postgres is telling you that it didn't run your query because it doesn't think that you finished giving it the instruction. So it's probably something like that. A table is returned. Yeah, sorry, this is a little wonky, but just for your FYI. So this is technically called a result set. That's just like some data science garbage, just no big deal. But after you do a query, what's returned is a result set. Or the table. I mean, technically this is like the entire guts of our authors table. So table would also be acceptable. Okay, cool. So that's working. We've got some dummy data in there. Let's walk through these SQL commands, the CRUD commands for SQL. And I'll put this just kind of for FYIs. And I think this will get us to lunchtime, so this will work out nicely. I'll probably just push kind of the lab portion. We had another lab for tomorrow to get some practice, so we can just combine it tomorrow. It's no biggie. But just really quick, if you want to take a look at that chart, you guys should be pretty savvy at this already. So have a little table with the CRUD or the CRUD action, create, read, update, delete, kind of the SQL statement that corresponds with that CRUD action, the HTTP verb that also kind of corresponds with that. And then that action column, we'll talk more about that when we get into Rails. That should look familiar to you, the create action, the index, the show. When we get into Rails, we're going to create actions for each. We already did this with Express and with we created our like HTTP requests and such, but this chart just has like some Rails controller action syntax in there. But the rest of this should be pretty straightforward. Create is insert, read is select, update, update, and then delete and delete. All right, so let's do some CRUD. So if you aren't already in your library database prompt, go ahead and get in there. And just in case you aren't, here's how we got in there. So we just typed in PSQL. You can enter the PSQL CLI. Again, it's a global. You can get in there from any directory, because remember that your Postgres database engine is kind of, it exists outside of any app or something. It's a separate entity on your computer. So you can get in there from anywhere. And then we did the \C to connect to the library database. So that's what we're playing around with. So go ahead. In the interest of time, I hate to be janky, I'm just going to copy these statements. I really hate to do that because this practice is good, but so the insert is how we create into our database. So that insert into, now, will this command run if I had lowercase insert and lowercase into and lowercase values? Would this still run? And then, close. I mean, so remember that it's just really a semantic thing. So when we're writing our SQL statements, the convention is to have the keywords uppercased. This should still run with lowercase, but it's a convention just because these things can get really difficult to read. So in the interest of readability, the convention is to capitalize the actual SQL language commands. So just letting you guys know, this should run fine if it was lowercase, but it's mainly a readability for humans issue. Okay, so we insert into authors. I'm going to insert the columns name, nationality, and birth year with the values of Adam Bray, who's a really awesome instructor. He was in DC. Now he's at Pivotal Labs, actually. He's a senior dev there. United States of America, and then 1985. So just to check out that we just inserted a new author row, I would do my select splat or star, select from authors, and I want to grab all of them. And so there we can see that SQL very nicely went ahead and incremented the new row with an ID of 9 to keep it sequential. And yeah, so selected was added there. Yeah, Zach, so that's a really good point. I may have skipped over it, my apologies. But SQL requires single quotes when you're, for strings, when you're writing these statements and queries. I don't think it'll work with double. It'll probably barf on you. It'll give you an error. But yeah, that's another convention of SQL, is that you want to use single quotes. Yeah, cool. And I think like if you have a, yeah, I think I had that earlier. I maybe just like glanced over it, but to escape characters in your like apostrophes and stuff, you would need to do the \, kind of escape character, proper nomenclature for that. All right, cool. So that was our create. Now let's take a look at some selects, which would be our read in CRUD. We took a look at the select splat from authors. Now, if you wanted to create a result set, so maybe I want to grab all the authors, but I only want to see the name and birth year columns in my result set. I don't really care about nationality or whatever. So the way that you could do that is you can specify. So instead of putting a star here, just like give me all of the columns, all of the garbage from my table, you can specify the columns and the order that you want to view them in. So you could do name, birth year. So select the name and birth year columns from my authors table. And there you go. So it's a nice result set with only the information that you asked for. So you can totally customize that if you want. And then the where statement, which is another way to kind of dial in your query to get more specific on what you're looking for. So let's say that I wanted to grab the author with the name of James Baldwin. So we could do another select, so I'm going to select all the columns from my authors table where specifically the name of a particular row, and I need to make that single, James Baldwin, like so. So there we go. So using that where statement is a really great way to kind of slice up and get really surgical with the information that you want. If you go through the documentation, and I think you may have to look some of it up for your exercises, you can also do where the birth year falls in between these two ranges, or is greater than this, less than that. So you can definitely customize with some operators. SQL has those available too. Cool. Okay. So two more. So let's take a look at update. So if I wanted to update, we're going to use that SQL, the SQL operator of set. So update my authors table and set the name equal to Adam B and the birth year of 1986, where the name of the row or the name of the author equals Adam Bray. This actually reads kind of weird, right? Because you think it would be like update the authors, find the row with the name of Adam Bray, and then set the name and birth year, to the following. But actually, I don't even know if that would work if you reversed it. It's interesting. This is just how the SQL documentation sets up these parameters. So first, you need to actually tell the table, then pass in what you're updating, and then the row that you're actually updating last. Anywho, so if we run that, we get an update 1, so it updated 1 row. And just to confirm this, so when we did our result set up here, Adam Bray, B-R-A-Y, had a birth year of 1985. And so now if we do select splat from authors, we grab them all again, right there. We can now see that we updated Adam's record. It's now Adam B, and his birth year is now 1986. So that's how we could do an update. And finally, if we wanted to delete a row, delete from my authors table where name equals Adam B, like so. And now if I do another select from authors, try that again. Maybe I had an extra character in there. Oops, sorry.
It did that to me too, and there was really nothing different. It's almost like it just needed.
Yeah. If I may have copied, if I copied that line from the README, maybe there's like some funky invisible character or something. I actually probably could have gone to like the beginning of that line and like hit the backspace, even though there's nothing there. Just a little kind of hiccup in Postgres. In any event, well, that didn't delete it. I probably did my statement wrong. What did I miss?
Semicolon?
Yeah, I was about to say, like, do as I say, not as I do. Yeah, let me try that one more time. See, I'm glad that happened because you can now see that it doesn't work unless you do it properly. So delete from authors where the name equals Adam B, and then that semicolon. Yeah, I thought that was weird because I was looking for like my kind of response here. So now if I do a select star from authors, now I can see that Adam, we got rid of Adam right there. Cool. Let me stop my screen share. So we're at lunch. I know that we didn't really play with the books. We're going to play around with the relationships tomorrow morning. So we'll revisit this app and play around with those relationships tomorrow. But any questions before we break for lunch? So we got a lot done today. We got Postgres installed. and we walked through some basic CRUD functionality in SQL.
I have a question, Mark.
Sure.
Is there an edit capability? It doesn't sound very useful to me right now, but I'm just wondering if there is one.
Well, the edit would be that update.
Well, because update overwrites it. Is there a way to not overwrite it?
Sorry, you mean create a new ID, like a new entry with the edited information?
No, like in Slack I put, like instead of overwriting nationality, you could add Sealandia to Adam Bray so that his nationality is now United States of America, comma, Sealandia.
Oh, yeah, you would need to put in United States of America, colon, Sealandia. Yeah, you couldn't join Sealandia to that. You'd have to replace the entire field.
Okay, thanks.
Yeah. Yeah. Any other questions? No, Jason, you could probably play around with that. You could write some code like client side to make that happen. But as far as like the actual query itself, you would have to do that magic. You could do that, but you'd have to write it with like Ruby or with the active record. So tomorrow we're going to get a taste of active record, which is the Ruby version of Mongoose. And active record is just really awesome. I think you guys really like it. So you could write some logic to do that, but you have to do it outside of the SQL statement. All right, cool. So I'll hang out for a bit if anyone has anything breaking or needs any help, but great work this morning. We'll finish all this up tomorrow morning with SQL and then hop into the Rails Ruby way to do this. So have a great lunch, and we'll see you guys this afternoon.
Actually, I have an error.
Sure.
I can't seem to shake.
Okay. Yeah, you want to share your deal?
Yep. So I loaded schema and everything down from up top, and go into here, and I try to insert it in both ways, and I keep getting this no such file or directory.
Okay. Exit out. So that PSQL-D library and such, that is not going to work. That only works from the command line. So that's PSQL-D library is definitely not going to work when you're inside Postgres itself at the prompt.
Right.
Let's do a PWD. Let's see where you are. Okay, so we need to be inside the library folder, the library SQL folder. So can we get into that? It looks like you aren't in there.
What I tried to do, like for some reason when I'm here, right?
Okay.
I have to sign into Postgres to do anything.
Okay. Yeah, you're on a Linux, huh?
Yeah.
Open up a new tab, like a new window. And then cd into that directory, like the library SQL directory.
Oops, what did I do? CD. Oh, CD. There.
Okay, so now go into PSQL. Role Eric does not exist. So have you been getting this?
Yeah.
Yeah, so this is a permissions thing. So Eric, is that Eric is your like kind of computer-wide user name?
Right.
Okay.
Right.
Yeah. So hold on one sec.
I know I've been getting this, and that's the reason why I have to do like a lot of sudo. Like when I install certain things and it won't let me, I need to do like a sudo apt-get instead of.
Have you been able to do any of the SQL stuff this morning? Or were you getting this error?
Pretty much no, because I had been getting this error.
Yeah, that's okay. That's a pretty common issue. We just need to like assign. We need to tell Postgres that a user named Eric has like permissions and stuff. So just give me 1 second. Let me find how we can do this. I think I had this in my troubleshooting notes.
I think he can just do, he can create DB.
Oh, create library. So go, yeah, do a create DB space from the.
Control C, Control C.
Yeah, from the prompt.
Control C up here.
Oh no, I'm sorry. Never mind. Your window is just smaller than I thought. You were bumped on the next line. I thought you were in another terminal.
Oh yeah.
Yeah, are you on the?
Yeah.
Are you at the prompt? Okay. Oh, that's your path. Yeah, do a create DB. And with no arguments, and just just hit enter. Can I connect to database? Role area design this. Yeah, we just got to create you a role. What happens if you do create DB space library? You're probably going to get that same issue.
Right.
Okay. Yeah, this is a pretty common one. Just have you Googled this? I'm just going to Google.
I was, but I think I was Googling the wrong thing because I was saying like no such file or directory. It just kept giving me this other error saying connect to server. So
yeah, you just need to like give it this role. We need to tell it that Eric can like use this database. This is a pretty common thing when you like first set up your stuff. But just let me see what we need to do.
Get gist with instructions here. Sudo u postgres ps.
Here, let me send you this. This sounds right. I think this is how I've done it in the past. So let's take a look at this. Let me send this to you, Eric. So click on that Stack Overflow. And I think this is actually Ubuntu Linux. So this should be really nice.
Right.
But essentially, if you scroll down to that answer, it says login as that user. For example, so your username is Eric, right?
Yep.
So it's not Eric at Stern.
No, it's just Eric.
Okay. So
Stern, that's the name of the computer.
Yeah. So let's let's try this. Do that sudo space su dash Postgres. Okay, then your password.
See, and that's where I was getting there before.
Okay.
And then create a user matching your normal. Okay, so create user. User. Does that work? Create.
What happens if you do PSQL?
PSQL.
Oh, there you go.
Well, but then again, I say create. I can say create DB library.
No, so create DB is that's from the command line. Now you're in Postgres, so you would need to do capital create.
Yeah, or \Q, and just do it from bash.
Okay, yeah, now you can do the create DB, yeah.
Create DB. See, this is where I was able to create the DB.
Created a library.
Yeah. So do PSQL space library. See if that'll just dump you directly in there.
There you go.
There we go. Do a \C. Sorry, a \L. My bad. Yeah. So right now, like your admin database, it's called Postgres. You see that second one. So that's because when you log in, or when you logged in that first time, you see how it says like Postgres equals pound.
Right.
That should say like Eric. That should say Eric, I think. So you're able to get in there. That's fine. It's just right now, like your default's going to be called Postgres. Your user is called Postgres instead of Eric. It's totally fine. If it gives you any issues, just let me know. But
well, it is giving me an issue. It is giving me an issue. So like if I do the what is it to insert the schema SQL?
Okay.
So if I do that, right?